Those magnificent men in their flying machines, they go up to the up, they go down to the down. They enchant all the ladies and steal the scenes with their up to the up, and their down to the down. Up, down, flying around, looking the loop and defying the ground. They're all rightfully keen, those magnificent men in their flying machines. They can fly upside down with their feet in the air. They don't think of danger, they really don't care. Newton would think he had made a mistake. He was a man and the chances they take. Oh, up, down, flying around, looping the loop and defying the ground. They're all rightfully keen, those magnificent men, those magnificent men, those magnificent men in the flying machine.
Hello, I'm Brigadier General James Abramson, and I have the good fortune to be the program director on the development and the acquisition of this airplane, the F-16. We're very proud of this airplane, and we think that it's going to be an important system for the United States, for our air forces, for NATO, and in fact for the free world. There are some very striking aspects of this airplane and this program. And the first one that I think you should look at are these 5 flags that are painted on the front side of the fuselage. They represent a unique endeavor on the part of the United States and 5 of our NATO allies to develop this airplane in a consortium. It's something that's really never been done by the United States before. And it's, I think, a new step in the usefulness of the NATO alliance and a way to bind that alliance together even more closely than it has been in the past. This program, I said, was unique. It started out in a unique way, as a prototype. And what we here at Wright-Patterson attempted to do was to define for contractors what it was that we wanted this airplane to do. And we gave them a very tough challenge. And then we said, now we're going to give you a lot of freedom and a little bit of money, and we want you to go out and to build us just the best possible system that can do that. And there were 2 contractors that started out initially in competition. One of them, the winner, General Dynamics. The other one was Northrop out on the West Coast. They both built very fine fighter systems for us. We then flew those in a test program, and all of this was done at very low cost. And because we gave them the freedom in the design to put together some of the advanced features that I'll talk about later, you'll see that they really came up with what has to be, I think, a bit of art and a good bit of engineering. As I said, General Dynamics won, and they won with this lightweight version of a fighter which can be used to counter fighters in the air, and we in the Air Force call that an air-to-air mission, or it can also be used to drop weapons on the ground and to support the U.S. Army in the field or the NATO armies in the field, and we in the Air Force call that an air-to-ground mission. And this one can really do both of these things and do both missions quite well. Some of the features that perhaps aren't obvious, but which really make this system work very well. The air intake is placed very, very carefully and in such a way that it feeds and supports a very powerful engine inside. This engine, made by Pratt & Whitney aircraft, is one that really is the key to the power, the maneuverability, and the heart of this fighting machine. That air intake is designed in such a way that you can flexibly fly at high altitude, at low altitude, and at very slow speeds and at very high speeds above Mach 2, or twice the speed of sound, without a lot of complexity and a lot of cost. And that's a tough job for any designer to, at low cost, get this kind of flexibility in a weapon system. Some other that are a little bit more obvious, perhaps, are this system right in here, this strake, it's called. And what this does, it's a special aerodynamic feature, and it causes greater lift to come across the wings of the aircraft. We can develop lift even when we're maneuvering it at terribly high G loadings. In this case, high G loadings above 9. You know, when we say high G loadings above 9, we mean that the pilot, when he's pulling the stick and when he's pulling that airplane in and making a very, very tight turn, the centrifugal force in the turn is forcing him down with 9 times the pull of gravity. Now, we don't do that just to make it tough on the pilot. We do that so he can outmaneuver an enemy fighter. And this airplane is so maneuverable that it can, in fact, turn inside the constraints of the Pentagon building. The wing itself and the way it's blended into the body gives us additional lift for such a system. Right here you can see the air-to-air missiles, which are always flown and which are always in place here on the wings, and this particular location on the wings gives you, again, additional lift, a more efficient kind of an airframe. Instead of having a stick that we have in most fighter planes that the pilot uses and that controls the way the airplane flies. When he pulls it back, the airplane goes up. This is his most important control mechanism. And on normal airplanes, those sticks are connected to a whole series of hydraulic lines and a very complex way of going all the way back and moving the control surfaces like this tail, or here, this flaperon, and this tail here. And that's a heavy weight, and it's a complicated piece of machinery. And what we borrowed from the space program is what we call a fly-by-wire system. And that means that the stick is just a little teeny stick that he has over here. That goes through a computer, and that computer is always helping the pilot fly at the most efficient possible position. And by doing that, with this fly-by-wire system, once again, we can do some very special things, some that are very subtle, but the important result is that we can outmaneuver any enemy aircraft that they've got now or that we see in the foreseeable future. Now, those are some of the technical features that I've talked about. Let me go back to those 5 flags and tell you something about the way in which we're going to build this system. We've combined these technical features in a nice, simple way so that we can make a low-cost aircraft. And of course, this was one of our most important objectives, because when we can keep the cost down, that allows us within a fixed budget to have a system that we can buy more and therefore ensure superiority in numbers in order to win a battle, as well as superiority in terms of a qualitative sense with the one aircraft. And I mean by this, we've got to be able to have a large number of aircraft available in a real fight. The low cost clearly is a benefit to the U.S. taxpayer. It's also going to be a benefit to NATO and the other taxpayers. Let's call out these 5 flags. Obviously, we start off with ours. The second flag, and it represents the Kingdom of Belgium. The third one, Denmark. Here we have the Netherlands, and here we have Norway. We have, as part of my system program office, which has the international management responsibility for this weapon system, we have 20 officers from those 4 nations who are just part of our organization. They add a great understanding. They also add a great amount of talent and a lot of excitement to the program. Some time ago, when this consortium to build this aircraft was announced, it was announced as the arms deal of the century. I think that there's a better way to describe it. Instead of the arms deal of the century, I think what it really is a new attempt, and the most complex attempt that we've ever undertaken, at multinational NATO co-production. Remember I said that General Dynamics was the prime contractor and that Pratt & Whitney was the prime engine contractor. Those contractors are really leading a multinational effort to build this. Instead of building this in one production line in the United States, as we have in many systems, we're building it in 3 production lines in 5 countries with 2 engine production lines. We now have placed in Europe about $1.5 billion worth of contracts on this program. They'll be making parts of the fuselage and assembling this aircraft in Belgium. They'll be making other parts of the aircraft and assembling it in the Netherlands. They'll be making electronics parts, engine parts in Denmark and Norway, as well as in the United States. This is the real challenge of this program, is to try to take this multinational industrial consortium and put it together in such a way that it's a benefit to the United States, it's a benefit to each one of our NATO allies that are participating, and in fact, then becomes a financially viable thing to do. The United States will be buying over 1,300 aircraft. The Europeans will be buying some 348. And then in addition to that, we've already announced that Iran will be buying a significant number. And what that adds up to at this point in time is a $22 billion program. An important piece of the action will be in Europe. We call this a swing fighter, and by that we mean that it will complement our principal air superiority or air-to-air aircraft, the F-16. It can do very well in that role, and it'll complement that with lower-cost airplanes. It'll also complement our specialized aircraft that are supporting the Army. The A-10 supports our Army, and it's an aircraft that's built especially for that job. But our airplane, with its flexibility, can do both missions. For one of the first times on a very large scale, the United States and the NATO Air Forces will all be flying a standardized weapon system. That means that American squadrons can land at a base in Norway or a base in Denmark or in any of the consortium countries. They can be supported by their air forces. They can work together in joint exercises with their air forces as they can work with ours. And this web of having a standardized system will greatly strengthen the NATO alliance. So we've got to be able to produce this at low cost and not exceed our portion of the budget. So low cost means 2 things. First of all, we have to produce the airplane. That's why the emphasis on simplicity and low cost in the design, so that we can buy it initially cheaply. But more than that, we're also designing it in such a way as to minimize the life cycle costs. And what we mean by life cycle costs are the costs involved with spares, the numbers of people to maintain it over the full lifetime of the weapon system. So we're trying not to take just the short-sighted view. We're trying to say the total cost is important to us. It gives us this low-cost aircraft, which can give us the numbers then, which can offset the tremendous numbers that the Soviet Air Force has in their inventory right now. We have to be very careful, because the Soviets are making a major investment in all parts of their military machine. They have very large numbers of aircraft. The best way to counter that threat is to produce an airplane like this one that's economical, one that has advanced technology at low cost, the kind of technology that will carry us well out into the future. This is an airplane that I think the United States can be proud of, and one that is going to be an important step for NATO as well as ourselves.
Those magnificent men in their flying machines, they go up to the up,